Good morning, good evening. Welcome to the Caterpillar Mining webinar series. My name is Attila Vecchini, Global Marketing Lead for Large Wheel Loaders, joining you from the Tucson Mining Center. And we're excited to bring you today's topic, Move More with Less, Increasing Efficiency with Cat Large Wheel Loaders. And with me on the call is John Merrick from Aurora, Illinois, Large Wheel Loaders Product Application Specialist. And you may find more information about him in the presenter bio section, as well as find important documents and links in the resources section. Now, before we get started, a word about Caterpillar's #1 value, safety. Be safe, be present, win the right way, be cyber safe. These are the values we live by, not just at the workplace during working hours, but during the rest of the day as well. And please note that this event is being recorded and will be made available for viewing in the future. Now, I realize that there may be dealers, customers, or competitors attending today or watching the recording later. So we just want to make sure that we don't share any competitive information that's sensitive. Basically, we won't be discussing today what's on the right-hand side of the slide, that is pricing, discounts, terms, and the like. Now, if you have any questions anytime during the webinar, please use the Q&A button and just type in your questions. We'll try to get to them almost as they come up, or we might wait with some of them until the end. Now, if you are an existing customer, feel free to contact your dealer with any specific information that you need. And also, if we get too many questions and don't get to yours, we'll follow up with you via email. Now let's run a quick poll, and we like to know a little bit about who's on the call so we can tailor the presentation to who's attending accordingly. So please select one of the options below. In what ways do you interact with CAT with the large wheel loader product? In what ways do you interact with the large wheel loader product? Are you an operator, or are you in mining or quarry operations? Are you in education, training, or research? Are you a mining consultant? Are you in purchasing? Or if none of the above, feel free to select other. And I'll just give you a couple more seconds, and we'll look at the results. All right, let's see. Okay, so we've got an equal number of mining and quarry operations, education, training, and research, mining consultants. Thank you. And with that, I'm going to turn it over to John Merrick, Large Wheel Loaders Product Application Specialist. John?
Thanks, Attila, and thanks everybody for joining. I hope there's some good questions today. So just a reminder in the Q&A box there, this is a live event. So as anything pops into your mind as I'm talking, please don't hesitate to put that question in and we'll do our best to get to it. So why are we here today? I want to break that into four elements. I've got another question on the screen here, and as I'm talking through these four elements of why we're here today, that'll help you to answer this question. So don't answer the question quite yet. So the first of all is the first element is there must be a situation. So you have we're talking about wheel loaders. So you have a machine with 4 wheels and a bucket, and there's a person operating that machine. So that's the basic situation. And then you must have then a problem, otherwise we wouldn't be here. So the problem, you could say, is that you have this machine that does 4 basic things. It travels, it digs, it lifts, and it dumps. And there's that person operating it. And there are many different ways for that person to do those 4 things. and that, and then if you take that idea that behind that person there's variability, we go into the third element of what are the implications of that problem. And so if you look at those things that the machine is doing, and the different ways the operator can do the traveling, do the digging, do the lifting, the timing of it, and the dumping, this can affect efficiency. So we're getting back to the title here, increasing the efficiency with CAT large wheel loader technology. It can affect the production, and it can even affect some of the component lives of the machine. So that's what's at stake. Those are the implications. And then finally, the fourth element would be what are you going to do about it? The need. So what do you need to do to solve that problem? And so I'm going to talk about both the technology and a little bit about what's behind it to begin with. So even if you're not in a situation where you're immediately going to add the technology to the machine, or we're in a position where you can have one of these machines with the technology, I still think that there will be something useful that you can take away from today. So with that in mind, the question on the screen of how sensitive do you perceive a wheel loader's efficiency, production rate, and component life to be to the operator's technique and skill? So that talks about the problem and the implication that I just referred to. I'm going to ask this again at the end because I'm interested to see if anyone changed their mind. So as it is today, and don't put too much thought into it, but just with these three answers: not sensitive, somewhat sensitive, or highly sensitive, how much does the results of the machine depend on the operator? That's kind of what this question is getting at. So go ahead now and decide your answers. I'll give just a few seconds here for everyone to get their answers submitted, and then we'll see what the results look like. Okay, I saw a couple more come in, so let's take a look. Okay, we've got highly sensitive, 79%, and somewhat sensitive, 21%. And nobody said not sensitive at all. So everyone's already a little bit convinced that there's a lot that can go wrong, you might say, with the way a wheel loader gets operated. So, and maybe that's why you're here to begin with, because you already recognize that. So let's get into the material now. I'm going to talk about a little bit of an overview, an agenda of what we're going to cover, and then we'll get right into the material. So, so first of all, to relate this back to the machine a bit, the three technology packages, so to speak, that I'm going to be talking about, the features, are available today as optional features on the 992 and 995 large wheel loader. The three features are called new Autodig Components. That's another way to describe that. That's partial automation of the digging. Operator coaching, we'll talk a lot about that feature. And then the third is a payload-related feature, CAT payload with Payload Overload Prevention. In terms of how these features are available on the machine, it's a software activation only. So you don't have to decide at the point that you buy the machine whether you want them or not. You can buy them either with the initial purchase, or you can buy it as after the fact and have it activated later without any physical changes to have to happen to the machine. There's also a 250-hour free demonstration or trial period on these three features that can allow you to see for yourself if they provide the value before you commit to buying them. And next, and this I'm just going to talk about here. I don't have a separate slide for it, so definitely if there's any questions on this, then go ahead and ask and I can elaborate. But this is a standard technology feature that's in the same category on the 992 and 995 that's called tip-up prevention. And what this does is it will not allow the operator lift the back end of the machine off the ground significantly. So full breakout forces are still allowed. It doesn't reduce your actual forces, but it stops your speed and your motion before you can actually lift those tires significantly off the ground. And so that helps prevent unnecessary stress on the drivetrain and structural components. And that's something that that we have as a standard feature because there's really something that we just thought that really everybody should have. So I'm taking a quick look. It doesn't look right.
John, we do have a question about this. Will the tip-up prevention reduce performance?
Oh, okay. Thanks, Attila. No, performance won't be affected, and that's because of that idea of the breakout forces. So you still are allowed your full breakout forces. And if you think about a wheel loader digging in a somewhat of a tougher blast condition, the force, whether you have the wheel 1 inch off the ground or 3 feet off the ground, is the same. And so you actually don't really gain anything at all by excessively lifting the back end off the ground in terms of how well the machine can dig. And so there's really nothing that it takes away. All right. Thanks, Attila.
Great.
And definitely interrupt me if anything else comes in. Okay, so the new Autodig Components feature, this is what I referred to as partial automation of digging previously. There's 3 elements to this feature. The first being the tire slip prevention. And the reason this is such a unique thing compared to what we've done in the past is because you have to look at the way that a wheel loader is operating. And I mentioned earlier, you have 4 tires, you have a bucket, you're trying to push into some sort of a pile or a blasted base. And as you lift with the bucket, and this is inherent of any wheel loader, no matter what the size or who makes it, the harder you push against, or the harder you lift onto the pile, the more weight comes down onto those front tires, and more weight's added to the front than what comes off the back. And so you get a traction benefit as you're digging, but that traction benefit comes and goes. And so what this feature does is when you have that extra traction as a result of that extra force, it's going to allow you higher rim pull. And when that traction goes away, it's going to reduce it. And it does this before the tire slips. So it's following up and down with your digging in order to allow you to have more rim pull when you can use it. And when you can't use it, it cuts it away. So it's not just preventing the tires from slipping, but it also is giving you that extra performance and that full force into the pile whenever you can actually use it. So that's the first of these 3 elements. Second element is tire set. What this is doing is, and this is related to what I just described on the first one, is in order to get that extra traction that I talked about, what this feature will do is automatically apply that first lift command. So what the operator would do in order to set the tires or pin the tires is to apply that lift command. As soon as you are far enough in to the pile where it won't pop up out of the pile, but also not too early. And this is something that the machine can tell when it's the right time to do that. And so the machine will do it for you. It'll give you that initial lift command. So it's actually taking over control of the machine. And that's an aspect of partial automation. And then after that initial command, and then you get a little further penetration into the pile, then the operator takes over and continues digging. If the operator was in a situation where they felt that they could apply that lift command before the machine itself, it doesn't interfere with an expert operator. So it's designed to both operate by itself or without interfering with an expert operator who might want it a little bit earlier. Okay, and then the third, lift stall prevention. This also kind of relates back to the first 2. As you are digging in any wheel loader, you have a pivot point that's up high, you have a bucket that's digging down low. And what happens because of that is the harder you push against the pile, the equal and opposite reaction is that the pile is trying to push the bucket down. So we're talking about lift hydraulics. When you run out of force to be able to continue moving, we call that lift stall. And so what the machine is going to do is when it detects that you have too much force or rim pull pushing into the pile, it's going to reduce that before your hydraulics stall and allow a fluid motion to continue. What all of these have in common is they all, when you're talking about controlling the rim pull, the left pedal or the impeller clutch is what does that, and the machine is controlling that for you. So that piece of the title that I have up on top called Full Automation of the Impeller Clutch is something that even an expert operator can treat it this way, where you can pretty much keep your left foot off the impeller clutch and let the machine do the job for you. And then what that allows for an expert operator is you can focus your attention elsewhere. And then for a lesser experienced operator or a lesser skilled operator, it allows you to use just the right amount. If you use too much of the impeller clutch, then there's a negative effect. If you don't use enough, there's a negative effect. So it allows you to get that just right.
Okay, John, we do have a question about Autodig, and it is, why don't you offer fully automated digging?
Oh, that's a good question. So the one really important element of this feature is that this works in all digging conditions. So whether this is a rehandled pile, say on a ROM pad, or an extremely well blasted face, this also works in tougher digging conditions. We wanted something that combines what the machine is good at, or what the computer is good at, you might say, with what the human judgment is better at. And so we broke apart those elements, and we're automating what the computer can be better at, but then we're leaving to the expert operator what the person is better at. And so when you're in a tougher digging conditions, you need that judgment. You need to be able to look at the fragmentation, the slope of what you're dealing with, whether there's a boulder sticking out. The computer doesn't know those kind of things. And so you combine the human judgment with this, and you get really the best possible result in terms of efficiency and production.
Okay, thank you. And there's a question about the gear lock. The question says, is the gear lock, I mean the gear lock number 1 and number 2 are correct in the 992 loader?
Okay. That's something I think we're going to need to follow up with later on. I'm not totally sure what that question is getting at. Generally, you would not dig in second gear. I'm not sure if that's the question or not, but when you're digging, you do always want to be in first gear.
All right, thank you.
Okay, let's continue on to the next. Okay, next is the CAT payload with payload overload prevention feature. This is something I'm not going to spend a whole lot of time on, but I do want to bring it up because it can be very important for some applications, especially when it's used correctly. In real world conditions, you oftentimes have a situation where there's variable density in the materials that you're operating with. And when you're talking about a wheel loader, that's even more common, because why do you have a wheel loader? Because of the mobility. Otherwise, you wouldn't be using something with wheels to do any sort of digging. And when you are having that mobility, it's probably because it's doing multiple jobs. And when it's doing multiple jobs in different locations, there's going to be variation in density. So when you have that situation, what this feature allows, the payload overload prevention aspect, is it will not allow the machine to be physically will stop it from being able to load a truck. By not allowing it to lift high enough to do that, it'll either stop or slow down the lift depending on what configuration you want if you are above a certain payload threshold. And that's up to the customer to enter that value. And so that's based on your target payload. So your density may vary, but usually when you're loading a truck, the number of that the payload is the same. So this allows you then to size the bucket to the worst case, which is the lower density, without rather than if you size to the higher density, then you really restrict your production rate on the lower density because you're running at a far less value than the rated payload of the machine. So this is to allow you to always be taking advantage of close to 100% of what the machine is capable of in terms of payload. Okay, any questions on that one, Attila, that have come in?
There is not on this one, but let's we can get to this next question. I think now it's about the 995. Is the 995 loader a new version of KitKat, and what are its most important features?
So 995 loader, and I did mention that in the beginning in relation to this technology. So the 992, which has been out for a little while now, has a brand new cab on it, a whole new operating environment, and along with that came this new technology. That same cab and that same electronics architecture and infrastructure on the machine, which enables this technology, is going to be on the 995. So it's going to have that same cab as the 992. It also, and this is the most significant aspect, has a higher rated payload that applies to the digging conditions that are more in a tough dig, so to speak. So you could say moderate to high digging resistance. And that's in the context of what is acceptable for a wheel loader to operate in. So I'm not talking about a digging resistance that's so high that a wheel loader can't do it and you could only use a hydraulic shovel. But in the higher end of the type of material you'd run a wheel loader, this is where the rated payload increase applies to. And it allows you to load, whether it's a 785 size class, 789, or 793 size class truck, you can load that in one less pass. So it's really all about the pass match. The reason I emphasize the digging conditions is because in the lower to moderate digging resistance, we already allowed a higher payload on the 994K. And so that higher payload in that certain type of digging is going to remain the same rated payload from 994K to 995. So in a lot of applications, you'll be able to take a pass out, but not all of them. And then across the board, this new technology will be available. And then there's a handful of other changes, of course, that went with it that relate to durability and serviceability, things of that nature.
Okay, great. No more questions on this.
Okay, thanks. Okay, now into the last feature. We have plenty of time to talk through this. This is the biggest topic here, operator coaching. And you'll see on the bottom of the slide here, when I was talking earlier about the implications of the problem at hand, efficiency, production, and component life. So if you look at an operator and all the different things that they can do, related back to that question I asked, in terms of technique and behaviors, those things can all be affected. And if you think in terms of how do you solve a problem, you usually have to be able to measure it. Before the operator coaching feature, there really wasn't a good way, or maybe not any way, to measure how the operator was getting to their results, what they were doing. So you could measure efficiency, you could measure production, but how did they get there? And that's what the operator coaching feature brings into the picture, along with, on the next slide here, along with videos that show, it's kind of like a self-help thing. So it's videos that show the incorrect technique. Now, I probably shouldn't call it self-help because the intention is you always would have a trainer. This is a tool for the trainer to help. It's not intended just to toss over the wall and have an operator train themselves. So this is a tool that you would combine it with a trainer, go through all of the videos and techniques, and then you can now measure this with a report for each operator of what they are, what tips they're following, what they're not following, or you could say what they're doing right, what they're doing wrong. And you can come back periodically, say once a month, and review and measure how one operator might get different results than another, and be able to then take that feedback and show that to the operator on here's what you have improved on, here's what we still need to work on to get everybody up to that same level across all operators. Basically, the goal is to get everybody as good as the best operator in terms of efficiency, production, and component lives on the machine. Okay, so let's get into some of the specifics. And these next 3 slides, these are actually I only have 3 slides left here. So I'm going to talk through a couple of these in a little bit of detail. As I go through this list, these are all of the things that the operator coaching is monitoring and measuring and then reporting back on. So there's 20 total line items here. And so you could say 20 different behaviors of the operator. And so that question I asked about how sensitive is a wheel loader to the person using it, these are all of the different sensitivities. These are all the things that can affect the efficiency, the production, the component life, specifically in each column here under the KPI, key performance indicators column. We list out which of these 3 things for each tip are affected. So I'll just pull out some examples here. So let's start with the first one, excessive travel distance during the V cycle. This is, I usually call this the low-hanging fruit tip. When you're truck loading with a wheel loader, you have a long V cycle, that is causing a lot of waste, so to speak, because you're spending fuel and time on traveling a lot further than you need to. So you still that engine running, power being produced, power being used, but it's not doing useful work. It's traveling further than you need. So it's slowing down your production, it's burning more fuel. And when you look at those two and add them together, the efficiency in tons per liter of fuel or tons per gallon of fuel drops. So tightening up that V cycle and being able to measure it is something that's really key. And that's tip number 1 for a reason. That's really the first, most important, most lowest hanging piece of fruit to improve. Now let's go into, let's use tip number 4 as another example, excessive left pedal usage when eco mode is not turned on, or you could say when HP plus mode is turned on. Those are both the same thing. So what this is describing, to use an analogy that I think everybody can relate to, would be, let's say you're driving your car and you're at a red light and it turns green, and you can see another red light and it's not very far down the road. So let's say you floor it, you give it full power and you go full speed into the next red light that's going to stay red, or say it's a stop sign, and then you know you're going to have to slam on your brakes, but you do that anyway. So then you go and slam on your brakes. So you've used a lot more fuel, but you didn't get to your final destination any sooner than a person who just slowly moved up to the next light without using their brakes. Now, if you're talking about a wheel loader, if you're running full power mode and that's too fast for you, what it means by excessive left pedal usage is you're slipping the impeller clutch and you're using the brakes to slow it back down. So you're producing power and you're fighting against it. Whereas what this tip would suggest to the operator is turn off the HP plus mode or the horsepower plus mode, or turn on eco mode, depending on what machine the coaching is installed on. And then you'll be in an appropriate situation. So the opposite is, if the operator can use the full power, so say that you're at that green light and you floor it and go full power, but off you go, and there's not another light or stop sign after you, that's fine. Go ahead and do that. And that's what this is saying here. If you can use the full speed of the machine, that's fine. Go ahead and do that. So it's not just telling you never use horsepower plus mode. It's trying to get you to balance the settings of the machine with the way the operator can take advantage of it. How about if I pause there? Attila, have there been any questions that have come up so far on the coaching feature?
There's one about the coaching feature. It is, are there any examples where you would not want the operator coaching feature?
Oh, sure. That's an interesting question. So I would say where you would not want it, I'll give directionally. So a lot of these tips you'll see, and as we continue to talk through these, are going to refer to digging and truck loading. Okay, some wheel loaders are going to do what we call load and carry operation, which means that they're spending a lot more time traveling, kind of acting like a truck, and a lot less of the percent of their time in the actual dumping into a truck, in the digging. So these coaching tips are mostly geared towards the digging and the truck loading part of the cycle. So let's say that you're in a load and carry application. Well, that could be where you need coaching the least, or maybe where you need it the most, depending on how you look at it. And the way I'll explain that is with how full you have the bucket. So if you have an operator who can get the bucket full, and maybe they did it less efficient, but you're doing that less of the time, do you need coaching as much then? Not quite as much as truck loading in terms of how much dollar amount benefit you're going to see in your operation. But say that there's an operator who, even with, forget the efficiency and the dig time, they just really can't get that bucket to 100% full. Well, now if you're traveling all that distance and you have a bucket that's only 80% full, and if the coaching feature allows you to get to 100% full, now that just switched you from coaching not having as much value to coaching having the most value, because once you are in that travel cycle, now that's a big penalty to have spent all that fuel and time moving only 80% of the bucket. So I think that's how I look at this feature, and when it makes the most sense and when it makes less.
Yeah, thank you, John. And I want to remind everyone, feel free to submit questions. Use the Q&A feature. I believe that's towards the bottom of your screen. And just feel free to submit any questions, and we'll get to them either during the presentation or right at the end.
Okay, so let's continue through here. Okay, number 7, tips 7 through 13. So you can see it's a long list of tips here. I'm just gonna pick another couple of these at random here. So let's go with the top one. That's an easy one. Bucket not level when entering the pile. So this is something that's not hard to do, but if your detents are not set correctly, so your automatic detent that puts that bucket in that level position, if the operator is not using it, or if they're just not paying attention, this will catch that and let them know. And that can make a big difference. If you're imagining, a machine trying to push into a pile and get a bucket full, and the bucket is on an angle that's kind of like trying to cut a stick of butter with the knife pointed sideways, it's just not going to work as well, and you're going to need more force in order to make that happen. So that's another example of one that's not super complicated. Let's see if we can find one that's a little bit more tricky. Let's say number 10, pushing a fully racked bucket against the pile at a high position causes excessive tensile forces in the tilt cylinder. So there, we're talking about component life. And so it's looking for an operator that's doing something that you typically wouldn't do, and you never need to do, but we know that it can happen. And so it's watching out for one of those abusive operating techniques and alerting through the system that that's happening. And then a trainer can come in and explain when it happened and figure out how not to do that anymore. Okay, let's jump to the next. Actually, let's talk about the last one. That can be an interesting one. So lifting the bucket higher than needed before dumping into the truck. So this is something we're really picky when we look at the technique, especially, let's say you're doing a production study and you're comparing two different options side by side of machines. We really don't want there to be any waste. And so let's say that the machine can lift high enough that the bucket is so high in the air that even when it's dumped, you can back straight out without hitting the sidebar of the truck with the bucket tooth. Well, in this case, that means that on all, except for the last one or two passes, you were actually lifting higher than you needed to. Because what that's doing is it's taking fuel to lift all that extra mass higher in the air. And then what are you doing with that? You're dumping it right back down into the truck. And now so you've spent more time, you've spent more fuel, and there's going to be more dust too, because you're dumping that from a lot higher than you needed to. So a really good operator will lift the bucket and the lift arm just high enough so that you can get that material over and into the truck, and then they will use the return to dig detent to bring that bucket back to the rack position as they're backing up in order to clear the sidebar of the truck with the bucket. Another thing about that is that the higher you lift, the less reach you have. Reach is how far across the truck. So when you're talking about getting the load centered, it actually helps you not to be lifted all the way. And so not only do you save time and fuel and dust, but you also more easily can get the load centered. Okay, let's pick a couple from the last, and then we'll get back to the questions. So let's go to number 16. Operator racks the bucket too fast without enough bucket penetration. This results in poor bucket fill. So that's getting into the digging technique. That's one of the things of the digging technique that's a little bit more invisible to someone that might be a bystander watching. And especially over time, that's something that if you didn't measure it through this feature, it would pretty much be invisible to you. Another one at random here, the operator number 18, the operator steers the machine while the machine is stationary. This reduces tire life. So that's a simple one, but it's an example of component life and an abusive technique. There's really not ever a time where you really need during a truck loading operation to be steering while the machine's not moving. That tears apart the tires unnecessarily. And so further wearing them out, especially if you just happen to be sitting on top of a sharp rock, that increases the chances that you're going to get a tire cut. So so watches for that, for example. Excessive dig time, that's another good one. That's an indicator that you either have the wrong size bucket or the blasting conditions need to improve. Or there's just a very poor technique that's leading to taking a lot longer than it should to fill the bucket. So a lot of the different things can lead to that tip being activated. Number 20, that might be related to one of the questions that was asked earlier. It's watching to make sure that you're not digging in any gear other than first gear. Okay, I'll pause there. Any other questions that have come in on the coaching feature, Attila?
Not on the coaching feature yet. We've got a question that we can just save till the end.
Okay, all right. Let's see if I can find.
Oh, you know what? Yeah, no questions yet.
Okay.
On operator coaching.
I went backwards to a couple of slides because I knew there was one that I might want to talk about that I had to find here. So tip number 3, excessive unracking in dig. That's something that is more common than you would think. And what that's saying is that an operator is actually, instead of racking the bucket back towards you, is unracking, so pushing back into the pile, or you could say wiggling, kind of wiggling the bucket as you dig. for some reason, a lot of operators are tempted to do that, but that actually is hard on the linkage structures, and it doesn't really gain you any extra efficiency or production rate. So there's not really any positive, but it does reduce component lives. So that would be an example of a somewhat abusive operating technique that this feature is watching for. Okay.
Okay, we do have a question related to this. What are the most prevalent tips that get triggered by a poor operator?
Most prevalent, I'll go to the top two. So the V cycle, the distance of the V cycle, that's for sure number one. Second most common that I've seen would be that one that I just talked about, tip number 3, unracking into the pile. And then for the rest of them, I mean, it's really kind of all over the place. We had most commonly with an experienced operator, you find 2 or 3 tips that they really habitually are an expert at doing wrong, you could say. You know, like you could have 20 years experience, but there's usually at least 2 or 3 that you can find where they just have a habit of doing something that's not quite optimal. So even with an experienced operator, and the change that you can get in your production and efficiency can be surprising how much change there is to, or how much improvement there is that can be had.
Okay, great, thank you.
Okay, I see a question from David. Why is the new model called the 995 and not the new 994? I like that one. The 994K, as compared to the previous generations of 994, 994F, 994H, grew significantly. You could say that it bumped up a size class, so to speak, you could argue. And so the one complaint that I was getting on that machine, 994K, is why didn't you call it a 995? And so as we came out with the improved payload capabilities and everything else that goes with the new machine, this was an opportunity to go ahead and do what you could have argued we should have done in the past. But that number moving higher indicates, okay, we've moved up in payload, we've moved up in size. This is not the size class anymore of what 994 F or H would have referred to. But at the same time, I do want to emphasize the trucks that it loads, primarily 785, 789, and 793 are the most common. We see the 994K operating larger than 793, but the most common would be 785, 789, 793. Those actually remain the same. The original 994 years ago was aimed at a 785. The difference being now, it's a lot higher production rate into it. So the production rate into those trucks has gone up a bit. Okay, so the question that I mentioned we were going to ask again at the end is back up on the screen. So go ahead and answer that. We'll see if that has changed. I forgot the number. Attila, do you remember the number when we started?
I don't. Let me see if I can. We could. Do you want to go back to that?
We can find out.
Poll results.
We'll use our technology to find out.
Okay. All right. Highly sensitive was 75.
Yeah, we were at 75.25. Okay.
Okay.
Let's see what we're at.
First time we asked the question.
Let's see what we're at now. We've got, looks like most people have submitted. A little bit of a change, so 86%. So I guess I've done my job here, that I've convinced at least a few people that the wheel loader is more sensitive to the human element than they originally thought. So that's kind of the whole idea behind this technology, is acknowledging that the machine is sensitive to the operator and that there's a lot of improvement that can be had. by being able to measure that, and then what you can measure, you can change and make that improvement. So measuring it is the first step. The operator coaching feature allows you to do that. One last thing that I didn't mention earlier. So we talked in the context of a 992 and a 995, so straight from the factory. This is something that if this feature interests you operationally, if you are, if you have anything from a 988K to a 994K, so a large wheel loader product we're talking about here, K series, 988K through 994K, and you think this may benefit you, ask your dealer about current and future offerings for a kit to be able to install one or more of these technologies, because that is something that we're working on. And over time that will change. So I don't want to specifically say what it is and is not available right now, but on a K series model, if that interests you, definitely check with your dealer and to see if there's the possibility of purchasing that kit to be able to retrofit onto the machine.
All right. Thank you, John. And we do have another question. How to keep the operator using the equipment efficiently? So how can we keep the operator using the equipment efficiently over time, even after the coaching has ended?
That's a great question. That's a great question. Thanks for that one. So the coaching feature, let's say that you buy the coaching feature, you have it forever. And in the case of the 992, for example, you saw 20 tips today. We used to not have 20. So that's an upgrade that's automatically happening to those, to that population of 992 machines where the coaching tips are expanding. It's an ongoing feature. And so in the most obvious case with a new operator, you're going to go in and have the trainer look at the results report for that operator and to measure until they get improved all the way. But now let's say they get to full proficiency, you can still go back, and maybe not once a month, but you can go back periodically just to check in to see if any of those habits have slipped backwards. And so you can still monitor, and I think it's something that should still be monitored, especially since conditions can change too. Things in the quarry or in the mine over time in operation may change such that it introduces new challenges to an operator where maybe a technique that used to not be relevant or a problem that used to not be there that the coaching feature would have detected and measured is there now. And so that might have crept up. So it's something I think that even with an experienced operator, you would want to check in and look at their report on their performance on an ongoing basis forever.
Okay, great. The next question is about chain usage on front wheels. What is the factory position with regards to chain usage on front wheels in large wheel loaders?
Yeah, the thing I like about that question is that front wheels specifically are referred to. So the tire chains are there primarily to prevent cuts from happening, because a tire cut, rather than like a slow, longer term wear, can cause a catastrophic tire failure. So if there's a situation where there are sharp rocks and the tires are susceptible to getting cut, then chains are a good idea. And they all of the large wheel loader product line is compatible with front tire chains. Rear tire chains we don't recommend. There are some customers who prefer to run rear tire chains, and some of the large wheel loader models can accommodate that. But before you put chains on the rear, you would always want to check with your dealer and make sure that that we've done our homework on that and made and checked on a few different aspects before we go ahead and add chains to the rear.
All right. Thank you, John. And we don't currently have any more questions. Some questions might be coming in later, but I know that there was at least one question that we didn't get to. We will send you an email to follow up if we didn't get to your questions. And thank you all for attending, and thank you, John, for the information. Do you have any last words before we break?
Thanks to everybody for their participation. It's great to see the questions coming in, and I hope this was helpful.
Yes, thank you, everyone. Thanks for joining us, and have a great rest of your day.